Hello, I'm Seok-Chan Lee, the developer of Open5GS. I'm very happy to be here in Germany after 6 years. I'm going to share what makes me about developing Open5GS. Why did I implement that feature in the first place, or what did I change the config file? I'm here to share those thoughts. Recent development. HTTP2 is the interface used by 5G, whereas 4G primarily used diameter, 5G uses HTTP2. And TLS is used to secure the HTTP2 protocol. As we will see later, the TLS is essential to 5G roaming to connect different carriers. So I was going to do this, but someone in the community implemented, so I can merge it. A new feature in 5G is encrypted IMSI. In 4G, capturing S1AP exposes the IMSI. In 5G, you can protect your IMSI with the SUSI scheme, SUSI. So next thing is the UPF high availability. When two UPF are associated with a single SMF, you can configure one UPF as redundant. So if first UPF goes down, the second UPF ensures the uninterrupted service delivery to the UE. Basically, this functionality was provided by Paul in OsmoDevCon. In order to monitor the various Open5GS processes, so we needed some sort of system for measuring metrics. So for this purpose, support for counters has been added to Open5GS by adding a kind of generic API for counter gauges of etc. For backend implementation of that API, Prometheus was used, which by default require an HTTP server to be running in the Open5GS process that serves the metrics. The Prometheus client library, Prometheus client C, actually contains two libraries, LibFrom and LibFrom HTTP. LibFrom implements the format of counter to pass to Prometheus, and the LibFrom HTTP is a very small library that provides an HTTP server that uses micro HTTP underneath it. One of the exciting features of 5G is the implementation of UEs, LAURL or CPs. You can implement this with the generic feature in 5G. This is through frame routing, which is described in TS 23.501, section 5.6.14. Normally, we assign a single IP to a UE, but frame routing allows us to assign multiple IPs to UE expressed in subnet. The simplest way to use this feature is to provide frame routing information to the subscribe database. You can specify the IP range that the UE router or CPE should cover in terms of mask bits used by the subnet, as shown in the screen. This feature is also available IPv6. The PFCP protocol was defined to pass data between the control plane and data plane. For EPC, the SCW can be separated into SGWC and SGWU. PGWs can be separated into PGWC and PGWU. In 5G core, SMF and UPF were separated from the beginning. Therefore, if one NF terminates abnormally, a context mismatch occurs. How do we resolve this? Heartbeat request response is exchanged periodically between control by the control plane and data plane. By checking this recovery time in the heartbeat message, we can determine if the other one has terminated abnormally. This allows us to restart abnormally terminated NF, which should recover the context. Suppose an SMF or SCWC in the control plane is abnormally terminated. If UPF and SCWU in the data plane detect this, it can simply detect UE information in memory. All PFCP information in control and data can start in the initialized state because if a data plane is delete all memory. The other thing is if you imagine that you have terminated with UPF and SCW for the first time, in this case, when SMF SWC in control plane detects this, it cannot just delete the UE information. This is because SMF has the FTEID information assigned by the UPF. Therefore, it is necessary to allow UPF and SCW to generate the PFCP information with the same FTEID. This can be done by sending PFCP session establishment message with a restoration indication flag. Next thing is SCPP. SCPP is an NF that was created for roaming in 5G. It can be deployed with or without SCP. Redesign of the Open5GS 5G core was required for SCP and SCPP. This is because they have different ways of discovering NFs. So therefore, I implemented SCP and SCPP as a top priority before all other features. NFs are deployed in the home and visited network as shown below. There are two SCPP in between, connecting home PLLM and VPLLM with the N32 interface, this one, between SCPP. And since the N32 interface needs to be secured, TLS is commonly used. Note that in the figure below, the SCP connection is omitted. And the other interfaces except the N32 are often deployed without TLS. To implement the 5G roaming feature, we should consider how to have users set up the TLS and N32 interface described earlier. But there are a few challenges to overcome. The configuration file used until 2.6.x was inflexible. First of all, the way TLS is configured is inconvenient. And N32 interface, which we described earlier, requires a new way to configure it. Also, N32 needs to be configured in two parts, N32C and N32F for control and forward, which seemed almost impossible in old configuration format. So I had to redesign it with a new formatted config file, and I set out to change all of this. First, if you look at SONAP, you'll notice that the keyword server has been added just below in SONAP. We see the GTPC has also added the keyword client. Previously, client is outside of MME, but we wanted to bring it inside. And to do that, I added the keyword server and client. In 5G, SCP is a client of AMF. NRFs are likewise client of all other NF. Therefore, I made them inside the AMF. So I'll explain why I did this later when I described a SCPP configuration file. Yeah, this is the new configuration. Let's talk about how to set up the SCPP. First, SCPP needs to be set up TLS for secure connection. TLS can be applied to multiple interfaces with a single certificate in common. So I added the keyword default for common use. to support this common approach. SCPP have a SBI interface in the same way as other NFs. Also, it requires an additional NF interface that is protected by TLS. This is not TLS, but N32 interface needs to TLS interface. So, if scheme HTTPS, this is TLS interface. This is N32F forward interface separately, but this is commonly same TLS certificate. So we are looking at an example where N32C and N32F use a common TLS certificate, but the interface is created separately. Client is the same, yeah. This example shows how to set up the separate TLS certification for N32C and N32F. So this is not used default keyword. It shows the TLS setting directly under the interface without using the default keyword, something like that. So I changed the configuration file format because of this feature. Roaming NRF, a network or carrier can be identified and distinguished by its PLNM ID. To use roaming with SCPP, the serving PLNM ID must be derived from in the NRF. Other NFs such as AMF and SMF receive the serving PLNM ID from the during NRF registration page from the NRF. Therefore, all NFs know which PLNM ID is used as the serving network. HTTP control information. So 4G uses diameter, but 5G uses HTTP control information. That occurs when UE connect is routed, in this case using FQDM. Operator identifier are defined using PLNM ID as shown below. Then complete the FQDN with the name of the NF, something like that. For HTTP control information that occurs when UE connects, we need to distinguish whether it is roaming or not. Let's take the authentication as an example. When UE sends an authentication request, the GNodeB, so some eNodeB receives it from the AMF, it sends the HTTP control information to the AUSF by HTTP2. If it is roaming, it sends it to the AUSF in the home PLLM. So roaming case, AUSF in the home PLLM. Otherwise, if it is not roaming, it sends it the AUSF in the local my network. Typically, the HTTP2 control information contains in the UE identifier. For AMF, it is contained in the HTTP control SUSHI format, SUSCI. It is shown in the figure below. The SUSHI contains the home network identifier, home PLLM ID. Therefore, you can compare serving PLLM ID previously received from the NRF with the home network identifier in the SUSHI format. In AMF, it is easy to determine whether HTTP2 control information in the roaming or not. But SMF do not have SUSHI information. It only knows the IMSI, which is derived from the SUPI, SUPI. As you probably know and have published, IMSI doesn't know if, so IMSI, so in the MNC is 2 or 3 bytes, they don't know about it. This means that the correct home PLLM ID cannot be extracted from the IMSI. So HTTP control information cannot be generated in the SMF. So here, Open5GS chose to use pool DNN. Pool DNN uses the FQDM method with the network operator created by the PLLM ID described earlier. The pool DNN is compared to the IMSI to determine if the MNC is 2 byte or 3 byte. So comparing pool DNN and SUPI. So I extract MNC is 2 or 3 bytes. So of course we can use the database, some database, so stored MNC and so stored MNC and MPC in case if So extract the database, we can examine the MNC 2 or 3 bytes, but current Open5G implementation is using this approach. But there is the risk of full DNN. So one problem with this approach, this is because the AMF made by different manufacturer may not send the full DNN. The standard documentation explain it this way for home routed. So let me explain what is home routed local breakout. And home routed roaming case, it shall be. So the AMF will send the full DNN. However, in local breakout approach or non-roaming, it says should be. This means that it may not be sent to the full DNN. Therefore, if you are using LB or local breakout case roaming, it will not work properly with Open5GS unless the other manufacturer sends a full DNN. So at this point, I have no good idea. So Open5GS implementation is like this. So far, we've talked about the 5G roaming. It was one of the most challenging things I've done recently. And I went on a bit long because I needed to explain why I had to implement it in this way and change the configuration file. Now let me explain what I'm currently doing. I still have some work to do on the roaming feature, and I'll also talk about OCS. So currently only LBO, local breakout, is implemented. As I mentioned, so local breakout means that the UPF is not, there is nothing. So VPLLM or UPF is internet. But home PLLM is the UPF traffic to the home UPF. So there is some, so because of this difference, home routed method requires SMF and NSMF in home PLLM rate, SMF and NSSF. So some property will be added to the subscribe database that distinguish whether the subscribe is local breakout or home routed, and I'll need to make it selectable in the web UI. In OsmoDevCon created metrics, but also provided the GUI interface. And so he's still making a lot of improvements. As soon as I finish the roaming functionality, I will implement OCS inside Open5GS. This is my current schedule, yeah. But Open5GS OCS, just current my plan is I'll make it minimal, very few feature. Yeah. So I add a property that can be set on subscribe database, some validate time or volume threshold. So I'll make them selectable in WebUI, but very minimum feature I will implement it. There was a suggestion from the community to move the WebUI and documentation to separate repository. Essentially, I think that is the way to go, but there are other things to consider. So there are better tools for the documentation, something like the Sphinx or whatever thing. WebUI also needs to implement some admin tool like the CLI. So the CLI needs to be, so admin tool like CLI is needed. So I wanted to move to another approach at that point, but currently I haven't, so they are still all together in the same repository. There are also some feature requests by community, so I don't know how much I can do, but yeah, I'm trying to do it, yeah. UPF performance test result currently shared, so the reliability of this test is unknown, but however, the performance of Open5GS is poor. So I started thinking about what to do with Open5GS UPF. To improve performance, we can think of the eBPF, XDP, and DPDK and VPP technology. So DPDK, VPP technology performs slightly better performance, but so NIC is limited. And is it a good idea to re-implement Open5GS UPF with a new technology, or alternatively, we can utilize an already developed eUPF or UPG VPP. So I'm still trying to figure out what to do with the UPF. So, yeah. So I work in order of priority. So bug reporting issues are prioritized. I also need to address security vulnerability. New feature can be implemented in the remaining time. So yeah, not much work. Yeah, yeah. This is my current situation. Yeah, thank you. Yeah, question? Yeah. Oh.
But I need one microphone here. Sorry. Yeah, I think it's on. Yeah. Wait, I have the question written there, so I don't forget. So if I understood correctly, you said that PFCP restoration feature is already implemented? PFCP restoration?
PFCP registration
is already implemented, right?
Restoration, sorry, yeah.
Yeah.
This is already implemented, so yeah.
Okay, because also something which I think it's kind of related, you may also may not be aware, or maybe you are, there's similar functionality for GTP v2c.
Yeah, right.
Which is called recovery, and in my opinion, that's one of the missing features for Open5GS to be used in real deployments for the similar cases as you implemented this. So I just wanted to raise the...
Yeah, so basically, I'm not sure. The reason is why I implemented PFCP restoration is this is essentially needed to deploy the Open5GS core. So at this point, I'm not sure, but without GTPU restoration, there is no problem, right? So at this point, I didn't implement it. But if this is must-have implementation item, so I need to implement GTPU restoration. So there is no report about it, from the community.
So I didn't get, do you plan, like, is it on your roadmap to implement it for GTP v2c, or?
So at this point, I'm not sure.
Okay, no, it's just fine.
Let me study about it. Yeah,
I was just interested to know. Okay. And also maybe also mentioning that the GUI interface, well, something we just talked about before, that seems to be only tested or used so far for the 4G network, so no real use on the 5G network yet. And I think there's even another interface there.
Current schedule is just the 4G because you implemented the GUI interface. So, but in my opinion, so adding 5G is probably easier. So after finishing 4G Open5GS OCSD, I will try to implement 5G OCS. Yeah.
More questions?
You said you are the Open5G developer. Is it really only you doing all this work?
Earlier time only one, but now 4. So probably 2 people.
It's quite impressive.
Hi. So since recently, I've been using Open5GS a bit more than I did in the past. And because I'm very used to OsmoCom, I'm always thinking, where's the VTY and how do I look at what's happening and in state inspection?
Sorry, I missed it.
You missed?
Where's the VTY?
How? Yeah.
VTY. Yeah. Okay.
So I mean, the question is to have. Maybe I'm just missing how one should do this, but looking at state inspection and seeing what's going on, is that something that is planned?
So CLI, so probably before 6 years, I would like to implement CLI, but delayed. Yeah. Basically, at this point, I don't know. So this is some different configuration. So OsmoCom use VTY shell configuration features, but Open5GS is YAML, so some different configuration. So and also from the community, people said to me, mostly Open5GS MF deployed in the Kubernetes environment, so some redundant, so multiple AMF, multiple SMF. So if they need to change the configuration, just down and change configuration and relearn. So, but even though I would like to implement CLI using some, my schedule is some HTTP2 protocol. Yeah. So I'm not sure when I can do it. Yeah.
I think the changing configuration is one part, right? But the main feature I think also Keith was referring to is what I would call state introspection. So, right, that you can just see how many objects exist, you know, what is happening in my network, what is the state of this subscriber, this kind of information. That I think is very useful, not just in a real world deployment, but also in lab and testing and so on. So you don't have to look at all the log, but you can just look what is the state now in this program.
Okay, you are right. So if the changing configuration is a very difficult feature to me, but showing statistics, some context information is, in my opinion, it is easy. So I promise I will finish until this year for showing context. Yeah, good point. Thank you. Yeah.